NEC 430.74 addresses the requirements for disconnecting motor control circuits. Specifically, it outlines the need for readily accessible and lockable disconnects. Regarding whether separate control circuit disconnects need the ability to be locked out, according to NEC 430.74 after each separately energized control circuit must have its own disconnect that can be locked out and tagged. Therefore, the answer is yes. Now, addressing the question of whether it's acceptable to use one control power disconnect instead of individual disconnects for each control circuit, the answer is yes, provided that the control power disconnect is labeled as such and is located at a readily accessible location near the motor or motors it controls, as per NEC 430.74 AON. Looking at a system that predates current code and how it would comply with NEC 430.74, consider that a system relying solely on a master control power relay, or MCR, to drop all control power and lacking provisions to disconnect individual motor control circuits would not comply with NEC 430.74. This is because the MCR only controlled the power to all of the control circuits collectively, not to individual circuits. When updating such a system, there are several recommendations to keep in mind. Firstly, install individual control circuit disconnects for each motor starter. Secondly, label the disconnects clearly to indicate the circuit they control. Thirdly, install the disconnects in a readily accessible location near the motor or motors they control. Fourthly, ensure that each disconnect is capable of being locked out and tagged. In addition to these recommendations, NEC 430.74b also requires that control circuit disconnects be capable of interrupting fault current. NEC 430.74c requires that control circuit disconnects be grouped within a single enclosure. NEC 430.74e provides an exception for certain types of control circuits, such as those for solenoid valves or interlocks. To summarize, the key considerations for complying with NEC 430.74 are firstly, providing a readily accessible disconnect for each control circuit or a labeled control power disconnect near the motor or motors. Secondly, ensuring that each disconnect can be locked out and tagged for safety during maintenance. Thirdly, verifying that the disconnect is rated to interrupt fault current. Fourthly, considering grouping disconnects within a single enclosure. Fifthly, understanding the exceptions for specific types of control circuits. The intent of these rules is to ensure that qualified personnel can safely de-energize and lock out motor control circuits during maintenance or repair, reducing the risk of accidental start-up or electrical hazards. It's also crucial that the disconnects are easily accessible so that they can be quickly operated in an emergency situation. The requirement for interrupting fault current is to protect the control circuit components from damage in the event of a short circuit or ground fault. By grouping the disconnects in a single enclosure, it simplifies the process of isolating the control circuits and reduces the likelihood of overlooking a disconnect. Finally, the exceptions for certain types of control circuits recognize that in some applications a complete disconnection of the control circuit may not be necessary or practical. When selecting disconnects for motor control circuits, it's important to choose devices that are specifically rated for this application. These disconnects typically have features such as a visible blade or a clear indication of the disconnect status. They also often have provisions for padlocking in the open position. The labeling of the disconnects is also a critical aspect of compliance. The label should clearly identify the circuit that each disconnect controls so that qualified personnel can easily identify the correct disconnect. The label should be durable and resistant to environmental conditions. In addition to the specific requirements of NEC 430.74, it's also important to consider the general safety requirements of the National Electrical Code. These include requirements for grounding, overcurrent protection, and wiring methods. By following all of the applicable requirements of the NEC, qualified personnel can ensure that motor control circuits are installed and maintained in a safe and reliable manner. Furthermore, consider the implications of the exception provided in NEC 430.74e. This exception allows for alternative disconnection methods for control circuits that operate devices like solenoid valves or interlocks, where immediate and complete de-energization might not be desirable or feasible. The code recognizes that certain control circuits are integral to the safe operation of machinery, and interrupting these circuits abruptly could create a hazard. Therefore, the exception permits the use of control circuit devices such as push buttons or selective switches as the disconnecting means, provided that these devices are readily accessible and clearly labeled. The specific requirements for these alternative disconnecting means are outlined in the exception, and it is important to carefully review these requirements to ensure compliance. Also, in updating an existing system, it's crucial to assess the overall condition of the wiring and components. Older wiring may be deteriorated or damaged, and it may not be able to safely carry the required current. If the wiring is found to be in poor condition, it should be replaced with new wiring that meets current code requirements. Similarly, older components such as motor starters and overload relays may be nearing the end of their service life. If these components are unreliable or have been damaged, they should be replaced with new components that are properly sized and rated for the application. When replacing components, it's important to ensure that they are compatible with the existing system. This includes verifying the voltage, current, and horsepower ratings of the components. It also includes ensuring that the components are compatible with the control system, such as the programmable logic controller or other control devices. In addition to the technical aspects of updating a motor control system, it's also important to consider the documentation requirements. The NEC requires that all electrical installations be properly documented, including the location of disconnects, the wiring diagrams, and the component specifications. This documentation is essential for troubleshooting and maintaining the system. It's also important to keep the documentation up to date whenever changes are made to the system. The documentation should be readily accessible to qualified personnel. Consider a practical scenario involving a motor control system in a manufacturing plant. The system controls several motors that operate various pieces of equipment, such as conveyors, pumps, and fans. The system was originally installed many years ago and does not meet current code requirements. The plant manager has decided to update the system to improve safety and reliability. As part of the upgrade, qualified personnel will install individual control circuit disconnects for each motor starter. The disconnects will be located in a readily accessible location near the motors they control. The disconnects will be labeled to clearly indicate the circuit they control. Each disconnect will be capable of being locked out and tagged. Personnel will also verify that the disconnects are rated to interrupt fault current. The disconnects will be grouped within a single enclosure. The wiring and components will be inspected and replaced as needed. The system will be properly documented. After the upgrade is complete, the motor control system will be safer and more reliable. The plant personnel will be able to safely de-energize and lock out the control circuits during maintenance or repair. The system will be easier to troubleshoot and maintain. The plant will be in compliance with current code requirements. When determining the appropriate disconnect size, several factors must be considered. Firstly, the disconnect must have an ampacity rating sufficient to carry the full load current of the control circuit. This information can be found on the motor starter or other control device. Secondly, the disconnect must have a voltage rating equal to or greater than the voltage of the control circuit. Thirdly, the disconnect must have an interrupting rating sufficient to interrupt the available fault current at the point of installation. This information can be obtained from the local utility company or by performing a fault current study. In addition to these electrical ratings, a disconnect must also be suitable for the environment in which it will be installed. For example, if the disconnect will be installed in a wet or dusty location, it must be rated for that environment. When selecting a disconnect, it's important to consider the available mounting space. Disconnects come in various sizes and shapes, and it's important to choose a disconnect that will fit within the available space. It's also important to consider the ease of installation. Some disconnects are easier to install than others. Also to note is that control circuits can vary significantly depending on the application. Some control circuits are relatively simple, consisting of just a few components. Other control circuits are more complex, involving numerous components and intricate wiring. Regardless of the complexity of the control circuit, it's important to understand its operation before working on it. This includes understanding the function of each component in a circuit and how they interact with each other. Before working on a control circuit, it's essential to de-energize the circuit and lock out the disconnect. This will prevent accidental startup of the motor or other equipment. It's also important to verify that the circuit is de-energized using a voltmeter or other testing device. When working on a control circuit, it's important to use proper safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves. It also includes using insulated tools. It's also important to avoid working on a control circuit when you are tired or distracted. When troubleshooting a control circuit, it's helpful to have a wiring diagram. A wiring diagram shows the connections between the various components in the circuit. It can be used to trace the flow of current through the circuit and identify any faults. When troubleshooting a control circuit, it's also helpful to have a multimeter. A multimeter can be used to measure voltage, current, and resistance. It can be used to identify open circuits, short circuits, and other faults. When troubleshooting a control circuit, it's important to be systematic. Start by checking the power supply to the circuit. Then check the fuses or circuit breakers. Next, check the wiring for any loose connections or damaged insulation. Finally, check the components themselves. When repairing a control circuit, it's important to use the correct replacement parts. Using the wrong replacement parts can damage the circuit or create a safety hazard. When repairing a control circuit, it's also important to follow proper wiring practices. This includes using the correct wire size and type, and making sure that all connections are tight and secure. After repairing a control circuit, it's important to test it to make sure that it is working properly. This includes checking the voltage, current, and resistance of the circuit. It also includes operating the motor or other equipment to make sure that it is functioning correctly. When working on motor control circuits, it's important to be aware of the potential hazards. These hazards include electrical shock, arc flash, and exposure to hazardous materials. It's important to take proper safety precautions to protect yourself from these hazards. This includes wearing appropriate personal protective equipment, using insulated tools, and following proper lockout/tagout procedures. It's also important to be aware of the potential for explosions in hazardous locations. If you are working in a hazardous location, you must use explosion-proof equipment and follow special safety procedures. Another important aspect of NEC 430.74 is the requirement for readily accessible disconnects. The term readily accessible is defined in the NEC as capable of being reached quickly for operation, without requiring persons to climb over or remove obstacles or to resort to portable ladders, and so forth. This means that the disconnect must be located in a place where it can be easily reached without any special tools or equipment. The purpose of this requirement is to ensure that the disconnect can be quickly operated in an emergency situation. For example, if a motor is overheating or malfunctioning, personnel need to be able to quickly de-energize the motor to prevent further damage or injury. In addition to being readily accessible, the disconnect must also be located within sight of the motor or the equipment it controls. This means that the disconnect must be visible from the location where the motor or equipment is being operated or maintained. The purpose of this requirement is to ensure that personnel can visually verify that the motor or equipment is de-energized before working on it. It's also important to consider the environment in which the disconnect will be installed. If the disconnect will be installed in a wet or corrosive environment, it must be rated for that environment. This means that the disconnect must be made of materials that are resistant to corrosion and moisture. It's also important to consider the temperature range in which the disconnect will be operating. Some disconnects are only rated for certain temperature ranges. The NEC also contains requirements for the marking of disconnects. The disconnect must be clearly marked to indicate its purpose and the equipment it controls. This will help personnel to quickly identify the correct disconnect in an emergency situation. The marking must be durable and resistant to environmental conditions. The marking must be legible and easily understood. In addition to the requirements for disconnects, the NEC also contains requirements for the overcurrent protection of motor control circuits. Overcurrent protection is designed to protect the circuit from damage in the event of a short circuit or overload. The overcurrent protection device must be sized to protect the smallest conductor in the circuit. The overcurrent protection device must be located at the point where the conductor receives its supply. The overcurrent protection device must be readily accessible. The NEC also contains requirements for the grounding of motor control circuits. Grounding is designed to protect personnel from electrical shock. The grounding conductor must be sized according to the requirements of the NEC. The grounding conductor must be connected to the equipment grounding conductor. The grounding conductor must be continuous and uninterrupted. The NEC also contains requirements for the wiring methods used in motor control circuits. The wiring methods must be suitable for the environment in which they are installed. The wiring methods must be installed in accordance with the requirements of the NEC. The wiring methods must be protected from physical damage. The wiring methods must be properly supported. In addition to the specific requirements for motor control circuits, the NEC also contains general requirements for all electrical installations. These general requirements apply to motor control circuits as well. It's important to be familiar with these general requirements when working on motor control circuits.